Please enter your 4-digit PIN now.
Welcome to the EPRI conference. Please hold to be connected to your call.
Presenting the second of 3 webcast sessions. The last remaining session will be on the 27th. It's a week from today, on Monday afternoon, 1:30 to 3:30 p.m. Eastern Daylight Savings Time. We did go beyond the 2 hours last time. I apologize for that. This particular session should run the full 2 hours, I suspect, because we did add a few slides. If you are participating in a group session, please forward the names of those attending to Tanya Holt at tholt, T-H-O-L-T, at EPRI.com. And Tanya's phone number should be on your screen right now. The quiz for CEU credit, it will be optional. It'll be at the end of each session. There'll be 10 questions, multiple choice or true-false. All answers are covered in the slides presented. Again, the test is optional. If you don't want CEU credit and simply want to take the test anyway, that's fine. You can do that too. To request credit, also contact Tanya Holt at the email on your screen. Again, tholt at EPRI.com. Our phone number is also listed there. To request CEU credit, you need to provide your Social Security number. We will review all the answers to the quiz questions immediately after. Webcast preliminaries, next slide. The material for the first session was posted to the internet. However, a few of y'all have called in this morning. The second session was not posted to the internet, and a lot of y'all wanted to make copies beforehand. I apologize for that. That is our fault. The reason being was we had the file was especially large. We had a lot of pictures in this section on maintenance. Excuse me, and we had to break up the file into about 6 different parts. So there's going to be some pauses in the middle of the presentation while we're swapping out PowerPoint files. As Julie just mentioned, you will have the capability of printing this directly from Microsoft Office Live Meeting. That's correct, Julie, right?
That is correct.
Okay, I believe so.
At the end of the session, so.
Okay. And like I mentioned, we will go over to the answers to the quiz right after the quiz. The purpose and scope of this webcast, we're going to be discussing breaker construction, operation, maintenance, and safety, and the emphasis is on maintenance. We're going to be talking today about tasks, tests, and inspections. In session 1 last week, we mainly covered circuit breaker construction and operation. The third session, we're going to be talking about cubicle maintenance and safety. This material was designed for power plant staff with limited knowledge on circuit breakers and circuit breaker maintenance. Veteran circuit breaker overhaul technicians will already be familiar with many of these topics. The course was originally designed for managers or other plant staff that are not familiar with breaker maintenance, or circuit breakers for that matter. The objective is to raise the level of knowledge and understanding of the purpose, construction, and maintenance of circuit breakers. The scope is limited to plant distribution breakers 15 kV and below. There's this course outline. I really just went over that. Today we're going to be concentrating on maintenance. Myself, again, I'm Jim Sharkey. I have previous experience as a Westinghouse main generator engineer, fossil plant engineer, and 13 years with EPRI and the breaker groups. Gene Langlois, who will be talking here in just a second, is with Waukesha Electric. He's got 8 years with U.S. Navy Aviation Support and 15 years with overhauling circuit breakers with ABB, Grand Eagle, and Waukesha Electric. You should see Section 2, Circuit Breaker Maintenance section on your slides there. And with that, I'm through with the intro, and I'm going to let Gene Langlois take over. He's going to start talking about Part 1, why perform maintenance.
Thank you, Jim. And I'm glad you guys could be here with us today. As again, Jim said, my name is Gene Langlois, and I have a couple of notes before we get started. Many of the slides that we're going to be talking about could be whole presentations in themselves. So the slides we could go over quickly, and some of the slides we could go over not at all. And again, as stated at the end of this EPRI webcast, you should be able to get into those and pause them to look at them, or you can print them for the slides that we don't spend a lot of time on. We're going to start off with Section 2, Part 1, why we perform maintenance. And I'll let you know when something's important you need to know. Very first thing off is why we perform maintenance. We perform maintenance for safety, cost, reliability. We must show that the breakers will work up to the point that they are changed out or overhauled. And it's important to note that three main reasons are safety, cost, and reliability. The slides you're currently looking at now, why we perform maintenance. An ounce of prevention may be worth $1 million and save lives, even your own. This picture was taken at San Onofre Nuclear Power Plant, and not only did it destroy itself in the cubicle, but it also destroyed the cubicles on either side, and it had some low voltage equipment that was facing in front of it that also received damage. And as stated, the insurance claim alone was $68 million US.
The bottom line is it took out the turbine as well, the turbine lube oil pump. And so it's catastrophic failure, not only for the breaker, but for the turbine and generator bearings itself. So.
And again, that ends Session 1, Part 1, why we perform maintenance. And the main reason we perform maintenance is safety, cost, and reliability. All right, now we're going to take a look at Session 2, Part 2, reference, documents, precautions and limitations, special tools, and equipment. I'm currently going to be looking at this slide. This slide is pretty much identical to the one that Jim Sharkey talked about in Session 5 on programmatic considerations. It is important to note that this information that you receive from vendors, operating experiences, and such is a living document. And after you have your references and procedures in place, it's important to update them or review them on an annual or whatever you deem is a correct amount of time between when they're written and the time that you actually perform the maintenance again. Some of the items that you're going to want to take a look at and reference in procedure. Again, test data records. The very first one is know who's doing the work. The next couple ones, equipment and atmospheric conditions. Know what and how and where the work is being done. Especially if someone else is doing the work for you, i.e. a vendor, this information would be important to note. And make sure that the information covers all the basics or all the bases. And one of the references that seems to work well came from Anita, and it covers most, if not all, the basic information. So we're going to take a look at some of that information.
And Gene referenced NETA, that's the National Electrical Testing Association.
Or International Electric Manufacturing Association. And basically what we're going to talk about is just going to take a quick look at some of these items, visual, even before you start to work, any type of work on the equipment, you want to take a visual look at it. You want to compare equipment nameplate data verify correct blade and alignment and blade penetration, travel, and most of that information you're going to get from your vendor's manuals. And verify each fuse holder is in good shape.
Yeah, I think blade should be breaker, right? Breaker alignment and breaker penetration, correct?
Well, actually, we have breaker alignment. Blade penetration is a different design. Some breakers actually have where the breakers come up and touch flat. Others are a wedge design or a knife design, so they slide in between the contacts, even on the moving.
Okay, so you're talking contacts.
Okay, that is correct.
Okay.
And next slide is a continuation, and you want to take verify tightness of bolts, test all interlocks, inspecting to indicate the control device for correct operation, and then the last three, or actually the last 2 or 3 items that we want to take a look at is we want to perform insulation resistance, measure, or contact resistance, ducting, and then you want to do a visual inspection even after you've completed your tasks. Cautions and limitations. First one, high pressure air should not be used. That's on PMs. On overhauls, you may want to use high pressure air to clean out, especially where your pins ride or the parts ride on certain pins. Item 2, wire brushes should not be used. Again, that's on PMs. On overhauls, they're very effective for cleaning, especially silver parts. Personnel should stay clear of moving parts. Item 4, care should be used when working springs with the springs in a charged state. Item 5 will be covered more later on about cleaning. 6, care must be used around energized circuits. 7, arc chutes internals may contain asbestos. 8, care must be taken when turning breakers on its back or side to prevent damage to the parts and or components. 9, care should be taken when working with different types of lubrication. And we'll talk more about that later, especially mixing lubrication, or sometimes some of the manufacturers have actually upgraded or changed the lubrication that they recommend from year to year. And 10, during overhaul maintenance, care should be used on springs that are being removed. They may contain energy, especially on some of the larger springs, such as the closing springs.
Gene mentioned a couple of safety items in there. We're going to cover safety in detail on the next session next week.
The next slide we're going to look at is special tools and equipment. More during overhaul than PMs, but some during PMs, and usually the first item is the following items may be purchased from the OEM or provided by vendors. And most of your PM type equipment can be, and you'll see that in the upper slide. Special assembly tools may need to be manufactured if unavailable from the OEM. And some of your vendors can also help you to acquire these special tools or make them. And that pretty much ends Session 1, Part 2. References, document, cautions, limitations, special tools and equipment. And we're going to move on and we're going to talk about, well, need a presentation. You just take 1 second. We're going to, you should be now currently looking at Session 2, Part 3, preventative maintenance. Now, we're going to spend some time on preventative maintenance. Normally, if you were doing an overhaul, which we'll be looking at here in a moment, you are going to perform incoming inspection. At the end of incoming inspection is where you will step into doing overhaul, and then at the end of the overhaul, you will step back into your preventative maintenance on outgoing. So how this is broken up is right now we're going to talk about preventative maintenance from beginning to end. Then we will take a look at overhaul and where and when it fits into your PM program. Very first item up on your screen is your molded case breakers. Most of them, as we talked about in session 1, are sealed or semi-sealed and have a limited amount of preventive maintenance or refurbishment that can be performed. And each plant needs to decide at what level it is cost effective to do maintenance on them versus replacement or upgrading to a newer design or model. As far as metal clad low and medium voltage preventative maintenance, we're going to be looking at as-found testing, cleaning, visual inspection, contact inspection, operational inspection, final adjustment, and final breaker inspections. As-found testing inspections. Perform as-found inspections and testing prior to performing any maintenance is good practice. And you'll see at the very bottom, we have a list of items, and for those of you taking the test, you might want to remember that. But these items, as a minimum, should be followed. And if you find any of the test data that is outside of what you expect to see, you should do some further investigation to see if there's a problem. And visual inspection is standard. Insulation resistance or measuring, low resistance testing or ductoring, and then we force gauge and reduce control voltage. These last two are very good indicators of the shape that the equipment is in as far as functioning. Force gauge will tell you if things are binding, and reduced control voltage will tell you the overall condition of the electrical, but no single test is a true indicator of the shape of the equipment.
One other thing, one of the real practical aspects of doing as-found is if you do find something significantly wrong with the breaker, if you, like Gene said, if it's out of spec, it kind of gives you a flag, especially if you're in an outage and you're under a time constraint. You can kind of adjust as needed there. So.
Next slide we're going to take a look at is general cleaning. When cleaning for most of PMs, you'll see that for the steel-plated parts, the electrical parts or the insulation parts are basically the same. You're going to wipe with a dry rag. If that will not remove whatever chemical is on there, you can use denatured alcohol. If you use any other cleaner that is more aggressive than denatured alcohol, you're going to want to go back over it with denatured alcohol to remove whatever residual chemical could be left upon the breaker. But as far as preventative maintenance only, just use a dry rag. And on the very bottom, you'll see that it's an important note that you want to be cautious with any type of aggressive measures on silver-plated parts, because the silver plating could be removed on some design breakers quite easily. Next thing we're going to take a look at is visual inspection, and we have another key note at the top, and for those taking the test, you might want to remember that. Visual inspection is only as good as the person who is looking at the equipment. And we have a list of items to be looked at. And we're going to take a look at some of them, obviously bent, loose nuts, missing cotter pins. Check the condition and arrangement of the wiring, check all electrical, and check that all rollers and pins move freely. And to continue on, we're going to check for the target accuracy. We're going to check the counters. We're going to show that the condition of the opening and the closing springs. We're going to check that all fuses and fuse holders are clean and there's no physical damage. that was a general overview of everything that you're going to want to look at as we continue looking at the individual or subcomponents of the breaker now. First one we're going to take a look at is the metal housing. It's important that it can support all the other subcomponents, and it is in good physical condition. And we have a list of items there that we feel is important. The next one we're going to take a look at is a primary insulation, and you should be looking at that currently on your screen. Now, this particular one is red, but other manufacturers it may be black or a different color. May need a flashlight to see if there's some sort of problem or cracking. Sometimes you visually can't see them with the naked eye. And many of the times you will see cracks where there's an insert and where the bolts will go through and are tightened down into the insulation. The next one we'll take a look at, you should be looking on your screen, is the racking mechanism. We also have a list of items, as well as when you're looking in the cubicle, you may see filings of some type on the edges where the racking mechanism would ride. And if you have any challenges with the breaker racking in or racking out binding, you're also going to want to take a little extra time inspecting the racking mechanism to see if there's any warping or damage. Next one we're going to take a look at, it should be on your screen, is the stored energy, electrically or manually system, as applicable. The general idea on this one is that the operating mechanism you're going to want to take a look at. Some of these items that are on there, you cannot check physically. You must actually operate to verify that it works correctly, such as one of the items is the puffer system. The operating mechanism actually operates that, so it's actually part of it. And then you're going to want to take a look at wear of spring charging mechanisms, the motor. We also have the racking system as well, if it has any interlocks that connect with the breaker. And limit switches. Along with the last slide, you may have a stored energy. Or excuse me, the last slide was the stored energy. This particular slide is a solenoid-operated mechanism. On top of all the items that we talked about with the stored energy, you're also going to want to take a look at thermal damage, freedom of movement of the armature, to verify that the coil is in good shape, as well as the mechanical parts of the operating mechanism. We're going to be taking a look at arc chutes or arc extinguishing mediums. Now, when we take a look at the SF6, the vacuum and the oil extinguishing mediums, most of these cannot be seen directly, and you have to gauge their indication of what shape they're in by testing, which will be covered later. Except for, as we'll see on the next slide, air magnetic arc chutes. These can be removed from above or around the contact structures, and you're going to want to take a look for any type of damage, and we have a list of some of the damage that you could see. Some of the most common are during the visual inspection: burns, cracks, and contamination. Contamination may be caused by when the breaker opens under sufficient load or a fault. You may get glass beads that will build up on the sides of the arc chutes, as well as some sort of carbon deposit. On some designs, especially the larger arc chute, and you'll see the red arrow pointing to one that goes to a manufacturer ABB, HK, the black edging can be cleaned off or cleaned out with a scraping device to to clean them off. But as long as there's no cracking or dielectric loss, it's still in good shape. Also, you may come across bad blowout coils. On larger design breakers, you may have coils that are used for magnetic draw to draw the arc up into the arc chute. These should also be tested. And typically, what you should see is less than 1 ohm. So next we're going to take a look at is primary disconnects and main current carrying parts. So we're going to be taking a look at this later on as well. But when you're doing your preventative maintenance, what you're looking for is the list shown. Some of the most common are overheating and plating loss. Also, the contacts, as far as the condition. And we'll be talking about that later as well. But as a general rule, these are some of the items you're going to want to do with your PM for your contacts. Now taking a little deeper at the contacts themselves, you're going to want to be checking for wear. As a rule of thumb, you want to replace contacts with 50% thickness of contact tip erosion. And that can be shown with the yellow V'd arrows in the upper slide. And you'll see that the one on the left is slightly longer than the one on the right. And that's caused by the erosion. Next item is small amount of pitting is normal, and that can be shown in the bottom slide of the arcing contacts, but is not true of the mains. The main should be true and smooth and not appear to have taken any type of arcing load. And for those taking the test, you might want to pay attention to the last item. Arcing contacts touch first and break last. Next one we're going to take a look at is secondary disconnects. We have a list. And when you're looking at the secondary disconnects, it's important to also look at the secondary disconnects in the cubicle to see how they made up. And next one we're going to take a look at is mechanical interlocks. Now there's many varieties of mechanical interlocks, so as well as the list, some interlocks may have to be tested by installing the breaker into the cubicle and cannot be tested directly on the breaker alone. We're taking a look at auxiliary contacts again. One of the other items we want to talk about is that what you should expect to see is with the contacts in the closed state is 1 ohm or less. And with the contacts in the open state is that they are infinity or very high. And typically, or A's follow the main contacts. So when the main contacts are closed, A contacts are closed, B's are open. When the breaker is open, B contacts are closed and A's are open. Next we've taken a look at current and potential transformers. Visual inspection is usually one of the key items you're going to use when inspecting any type of CT and PT. But there are some tests that can be performed, and we'll be taking a look at those when we start talking about the testing. And one of the main ones when we test is the ratio testing and continuity. Internal control wiring. Along with the list, most electrical components cannot be visually seen if they are bad. You must do some sort of testing to verify their operability. One of the key important ones is the shunt trip test. So we're going to spend a little more time taking a look at that along with a more detailed list of what you're looking at. But again, your shunt trip, this component cannot just be visually inspected to verify the condition. We'll take a look at overcurrent trip devices. Again, as we spoke about in Section 1, as we move from electromechanical to more modern types, and then finally on to actually programmable or logic-based. You cannot visually inspect them alone. You must actually test them to verify that they are operating and in good condition. And we have more about that when we take a look at in 3 next week. Under voltage trip attachments, along with visual inspection and the other list, they need to be tested to verify if they're good and that if it has some sort of time delay, which is shown in this particular slide, you're actually going to see a small unit that provides time delay. It needs to be verified it's within the correct band. Bell alarm. We have a list of items you need to check for the bell alarm. And one of the items that should be checked just before you install the breaker, when you're doing your preventative maintenance and you complete your task, is you roll the breaker out in front of the cubicle, getting ready to install it. It is advisable to check the bell alarm one more time to verify that during movement you didn't cause any problems or disturb the actual latching. Auxiliary switches. We have a list of items to look for, and care must be taken if replacing. The contact sequence may not be the same as one pulled out of stock as one that is already on the breaker. And you need to verify orientation of your A's and your B's before and after installation of your auxiliary switches.
This is Jim Sharkey. Some of y'all are mentioning through the web manager here that there's a delay between the slides. I'm not sure how to resolve that, but anyway, we'll try to pause a little bit between slides maybe, and hopefully that'll help.
If they are having technical problems, please make sure that they have cleared their cache, or they can call into customer care and press *0 as well.
Okay. Thanks, Julie.
Oh, you're welcome.
Appreciate it. All right. Moving on.
All right. The next item we'll take a look at is the Kirk or keyed interlocks. One of the most common is the manufacturer Kirk key. And we have a list of items, as well as verifying that the interlocks work correctly. We have local operation, and some of the secondary wirings may not be the same for your local as for when the breaker is installed in the cubicle. So it's sometimes important to check the operation of these when it's on the bench. Fused breakers. We have a list of items to look at for fused breakers, and we'll be talking more later about how to test the fuses and the fuse indicators. That pretty much completes the section of what you want to do with visual. Now we're taking a look at the final adjustment. We're going to be taking a look at the contacts, physical measurement, over travel and gaps, and the interlocks. And we have a little note that not all manufacturers have the above listed items. Some may have other items than what is listed and covered. And of course you want to use the reference manufacturer's manual when making final adjustments. One that is usually typical of all breakers is main contacts, is simultaneous make and contact pressure, also called penetration or wipe. And we're taking a look at this at next slide. First we're going to take a look at is contact pressure. It's also called penetration or wipe. Contact pressure is a distance the moving main contact goes into the stationary main contact after they first touch, hence penetration. And you're going to see we have two slides with this particular manufacturer. The next one we're going to take a look at is simultaneous make. Along with the items that are listed, simultaneous make is when all three phases touch at or approximately the same time. And in the very bottom slide, you'll see a little red arrow. That arrow is pointing to a maintenance handle. Some designs, you actually have to install a maintenance handle and capture the closing springs to perform this task. One of the other common you may have is contact gap, and it's the distance between the arcing contact moving and the main contact stationary when the breaker is in the open state. And what we're looking at here is if this breaker opens under catastrophic fault conditions, the contacts have to move far enough away that the breaker has the ability to quench or extinguish the arc. And as we spoke about earlier, when we were talking about the knife wedge design with myself and Jim, you're going to see where the two arrows point. And you're going to see that the arrow on the left has a knife. And if you look on the right, approximately at 6 inches, 5.5 inches, you're going to see where that knife blade actually wedges itself inside, or hence knife wedge design. Many breakers and vendors set latches and over travel in many different ways. So we're going to be talking in generality between these two. The very first one to take a look at is physical measurement. Most all manufacturers and most all designed breaker equipment will have a clearance between the latches when they are set. Very important. When the breaker's set up, you should expect to see some sort of clearance between the two moving parts. Beyond that, that's pretty much what you're going to be looking for. Now, there's one other thing on all breakers and all designs as far as taking measurements that you're going to want to see, and that is over travel. Especially on your trip latches and your closing latches. Most of them have you set up and then back off until the breaker trips free or the latch cannot be set, and then to turn it in or set the latch or over travel to a certain degree. Very important when you do these two measurements, not only do you use the vendor's information, but common sense needs to be applied as well. As we talked about in section 1, we're going to take a look at interlocks and racking interlocks. It's very important that the springs will discharge during breaker rack out for the very first item. And we have a list of others. On this particular slide, we're going to be taking a look at the operating circuit breaker, including racking through the different positions. And we spoke about this in session 1. And we pretty much gave another outline as breaker cubicle interlocks. And again, not all breakers are available to be charged while in the racked out position. And as spoke about in session 1. One of the other items is operational inspection. It's very important, as we spoke about in the very beginning, that the technician performing the task is qualified. One of the main items that having a qualified technician look at the equipment is audio, as well as visual testing. And the very last item is binding of racking mechanism, for example. And then we have some items for final breaker inspection. Again, you want whoever is performing that task to be qualified. All the items are visually inspected by another person doing the inspection. And that all adjustments that need to be made should be verified at the same time the adjustments are made. Now what we're saying here is an item, second item, is that the inspection should be made by another person. If they cannot be, then item 3, or the third bullet down, they should be verified at the same time the adjustments are made. And again, we took a look at some of the items for inspection. Cleanliness, hardware, wire rotting, disconnects, upgrades, interlocks. And then breaker as left testing. Now, beyond the items that we spoke about during incoming testing, you should use the manufacturer's recommendations, as well as any other test that is required by your plant. And the main goal is, with as-left testing, is to verify that the breaker is going to operate not at that moment, but operate up until the time you get ready to remove the breaker from the cubicle, to change it out, or to overhaul it again. And that pretty much ends the preventative maintenance. Now what we're going to take a look at is Part 4, refurbishment and overhaul.
This is Jim Sharkey. We realize a lot of y'all, especially maybe the fossil plants, may not be using or doing overhaul at the site. What we're trying to do here is just give y'all an understanding of what's involved with the overhaul process. It's not trivial, and there's a lot of subtleties and a lot of knowledge that needs to go into any breaker overhaul. So. But anyway, Gene's going to give you just an overview and cover the high points of breaker overhaul.
As stated, basically with the molded case, or sealed or semi-sealed, there's no real overhaul that I'm aware of that is actually performed to a good degree. So we're going to be taking a look at low and medium voltage breaker overhaul. And again, this presentation is beyond the scope and course for anyone who's going to be performing the overhauls. It's basically a guide to, if you're having your breakers overhauled or you're planning to do your overhaul, items that you definitely want to consider and raise the awareness. We'll take a look at steps for overhaul. We'll take a look at disassembling the breaker, cleaning, inspecting the parts, ordering new parts, inspection of new parts, if required, cleaning new parts, and assemble a breaker. Very first one to take a look at is the disassembly. Most of the time, after you complete your incoming testing, at the end of that, then you will completely disassemble the breaker. And as stated, all piece parts of the breaker should actually be taken apart and removed to the point that you can inspect or visually see all the pieces. Removing of lubricants from the breaker. We have a list of items, and while doing this, it's important to use the least aggressive means to remove the old lubricant from the pieces, so not to remove the plating. There's also, again, cadmium. There's a heavy metal. Newer breakers and newer design breakers use yellow zinc. Cleaning silver parts. We actually have a new part and a silver oxide. Now, silver oxide is as good of a conductor, if not better, than silver itself. And for those taking the test, you might want to remember that. Silver oxide is as good of a conductor, if not better, than silver itself. So it's important to remove the old lubricant, but not necessarily the silver oxide. When cleaning silver parts, a tumbler or bead polisher works very well. Wire brushes are as good for cleaning silver parts. You want to stay away from using any type of sandpaper or abrasive pads. So that's basically, we took a look at cleaning. Now we're going to take a look at inspections. You want to inspect the copper pieces or any type of silver-plated copper pieces, or any type of removal of the silver. Some manufacturers have a 0% silver loss on the copper or conductive carrying pieces. And as in the picture, you will see that the parts are inspected after the cleaning. Metal part inspections. Along with our list, when you disassemble the breaker, you want to inspect the parts for any type of wear. As a rule of thumb, on your pins, if you run your fingernail down it, and your fingernail will lodge into the piece or get stuck, it's normally rejected. Most parts on most design breakers are hardened to some degree, or surface or case hardened to some degree. If you lose that surface hardening, the pins will wear out. Bearings, as spoke about. If you're not replacing the bearings, you do not want to remove them from the guides. Most overhauls will replace bearings. And then check for crack welds, deformed parts, and when you're doing your inspection on your parts, do not assume that the part is correct just because the breaker was functioning. Insulated parts. We're going to look for overheating, tracking, cracks, and as we spoke about, when you have it in this state, you're going to want to look where the hardware bolts into or through the insulated pieces. And you'll see that sometimes you can use a flashlight to inspect the parts. They'll show hairline cracks that can't be seen. Optional equipment inspections. Now in section 1 we spoke a lot about many different types of optional equipment. Use the instruction manuals provided by the manufacturer as well as common sense. Breaker lubrication. During PMs, you rarely need to lubricate any parts on the breakers except for the primary disconnects. And if some manufacturers use oil, you want to use it sparingly. And you want to also keep in mind, especially if you're taking a test, one of the most common lubrication errors made is over-lubrication. Over-lubricating can be detrimental, and excess of lubrication can...
Excess lubrication is basically a magnet for contamination. So that's one of the reasons why you don't want to over lubricate. One other part I'd like to comment on. This is webcast going out to a lot of plants. Gene said you will rarely need to lubricate breakers during a PM. Obviously, if you're that depends on the circuit breaker. If your maintenance if your equipment, your circuit breaker maintenance manual from the manufacturer says you need to lubricate, then obviously you need to do so. But I think Gene's speaking in general, it's generally not needed.
And I also agree with what Jim said. That is a true statement. One of the main items to keep in mind is a primary reason breakers tend not to work is hardened lubrication. Tends to fail in the breaker before parts, or the electric parts, or the contact.
And that seems to contradict what we just said, but really lubricant is embedded throughout the operating mechanism, and you can't really get to it during the PM. And so if you're PMing a breaker, there's sections of that operating mechanism you will never even see or touch. So if the breaker hasn't been overhauled in quite a long time, then it can definitely fail due to hardened lubrication. And like Gene said, that is quite common.
The slide you should be looking at is one of the last slides on lubrication. And the basic idea is if it's in a relatively cool and dry environment, the equipment will work longer. As the environment becomes harsher, then the lubrication will tend to dry up and fail sooner. And so you have a temperature, there's a temperature actually given of 104 degrees Fahrenheit. That was actually done by a study by EPRI that looked at equipment above and below that temperature. It's not an exact science. That just says that somewhere around that particular temperature for extended periods of time, they've seen adverse conditions to the equipment. And more to talk about lubrication in session 3. We're moving on to the last part of it, assembly. Just because you take it apart one way does not necessarily mean you want to assemble it in the same order you took it apart. Typically, most people can take anything apart, but it's important that when you're assembling the breaker, when you get to a certain step, that the parts cannot be seen later on, hence be put inside of a container or a subassembly built up into a larger subassembly, and it can't be viewed. That there's some sort of check or quality assurance, or another qualified technician look at that part before those subassemblies are put together and then built up to a larger subassembly and then to a breaker.
The reason why it may not go back together, correct me if I'm wrong, this is more of a question to you, is I think the point you're trying to make is that the breaker may not have been assembled correctly in the first place. Is that what you're saying?
Yes, you can come across it. Just because you find it that way, that's a very good point. Yeah. Just because you find it that way doesn't necessarily mean it goes back that way. And sometimes it's much easier to take something apart than put it together. So when you're assembling a breaker and you assemble a subassembly and you install it into a breaker or another large assembly, you want to make sure somebody else looks at it.
I went to 5 and 6.
All right, and that should pretty much complete the overhaul. Now, we were taking a look about on this particular one, Session 1, Part 4. Don't pay attention to all the slides bouncing around, just that one. Now, what we're looking at here is refurbishment and overhaul as far as preventative maintenance. As spoke about, you will perform all these tasks and then step into the as-left testing of the breaker. In other words, you're going to redo all the visual inspections that were performed in the preventative maintenance. And then you're going to check your latches, latch bites, and then do your testing as stated in the preventative maintenance. And as soon as we get to the correct part, we're going to be taking a look at Section 5, which is test, and I think we're all with you now. There we go.
Sorry, that was my fault.
We're just trying to help you guys out with the test.
That was the preview of the quiz, by the way, courtesy of Jim Sharkey.
We're going to look at Section 2, Part 5, the testing and test equipment. Now, it is necessary to make informed judgments for each particular test regarding how and the extent of the testing that you're going to want to perform. You may want to consult an outside vendor and or the manufacturer to come up with specific tests at your specific plant or in your specific situation that will, as said earlier, will give you confidence that the equipment is not only in good shape as left, but will perform its intended function until you're ready to remove the equipment from service or overhaul it again. And keep in mind, common sense, along with the instruction manuals. The very first one to take a look at is thermography. Basically, thermography will look at hot spots. It sees in infrared or in heat range of the visible spectrum. One of the items is that you want a good piece of equipment that can see a 1 degree change Celsius at 30 degrees Celsius. And for those taking the test, keep in mind that when you're doing thermography, the equipment has to be loaded. The higher it's loaded, the percent of its rating, the better. Most manufacturers require at least 40% before you're actually going to see any type of hot spot on the equipment.
Yeah. And couple other comments. Obviously, most plants these days have thermographic equipment or they have a service that comes by. Very effective on motor control centers and the lower voltage, ice phase bus, that type thing.
Now, when you get to start the larger type breakers, such as your metal-clad low and medium voltage, you can use thermography except for the fact that with the arc chutes, phase barriers, and protective coverings, you may not actually see the hot spot as shown in this picture here. You may see heat or a warmer spot somewhere, but nowhere near as good as in this picture.
The other comment I wanted to make was you should note that thermography cannot detect corona damage. There have been some cases where on medium voltage equipment thermography has been used effectively. There's been some, type like a bus problem or some type of overheating, or it heated the general area, and thus you could tell it even on the outside of the equipment, on the cabinets themselves. It can be done, but it cannot detect corona because corona does not develop that much heat.
We have several slides that we're going to take a look at on measuring. Insulation resistance of circuit breakers is a must-do test and should be performed as found and as left. And one of the items that we're going to talk about in the very last sentence is shaking the parts. What we're trying to get at, especially with the arc chutes, on certain design pieces of equipment, you can actually move the arc chute around and watch the insulation value change. More on insulation. Some of the most common tests that should be or must be performed are line to load, breaker open, phase to ground, breaker closed, and phase to phase with breaker closed. You want to investigate any resistance value that deviates by 25% or less. Now, when we use common sense when we say 25% or less, we mean when it starts to get close to its limited or its lower values. Obviously, if it's in the gigaohms range, it's thousands of times higher for a 480 volt breaker than it needs to be. We have one more slide, and we're be taking a look at the control wiring. Now, one of the rules of thumb is 1 mega ohm plus 1 mega ohm for 1 kilovolt, or, not and, should be 2 mega ohms. So in other words, if you have a 5 kV piece of equipment, you're measuring it, you would expect to see 5 mega ohms plus 1 or 6 mega ohms. When you start getting into control wiring, there tends to be some question as to what is acceptable. Most vendors require, as said, 2 mega ohms, except NETA, the International Electric Testing Association, has some criteria, and that is for 250 volt wiring test at 500 volts DC, 25 mega ohms at a minimum. And then for 600 volt wiring, test at 1,000 volts DC. At a minimum, you should see 100 mega ohms. And keep in mind, solid state components follow the manufacturer recommendation.
Seems to be a significant delay in the slide changes here. We're pausing in between these slides as best we can, so bear with us.
Now, one of the other most common must-do tests is low resistance ohm meter or conductivity testing. This particular test uses a specific amount or exact amount of current and then looks for a voltage drop and will either give its values in a resistive number or a voltage number. If you run into challenges with these not meeting the manufacturer's minimum recommendations, you can look for problems by breaking the circuit in half and then looking for whatever part of the circuit is higher than what is expected or higher than if you were to look at all 3 phases, if you could then find a piece of that circuit that would be higher than the other 2. And we've also had challenges with this particular test not meeting the minimum manufacturer's recommendation, contacting the manufacturer and them saying, that's okay. And when you're running your equipment, the instruction manuals are written for a cushion. So they're more concerned that you're running the piece of equipment at its peak operating load. So, i.e., if it's a 600 amp breaker, that particular ohmic value or low resistance value is if you're running that circuit breaker at 600 amps. If you're running it less than that, you need to be less concerned. But again, you must use common sense.
Well, we're trying to change the slide here. Hopefully it will here in a second. Oh,
And while we're here,
Do you want to be on primary injection?
Actually, we were on the slide before it, slide 8.
Okay, so you need to be back on slide 8.
Yeah.
Okay.
Okay, we're on slide 8.
Okay, great.
Very
Sorry
good.
about that.
Thank you.
ohm meter and continuity. These are not necessarily the same tests, even though they're talked about on the same slide. An ohm meter is a ohmic value, such as if you were looking at a coil, pickup coil, or a trip coil, something along that lines. You're looking for a band of acceptance. When you start looking at continuity, it's a go, no-go gauge test, if you will. And when you're using continuity as a rule of thumb, you would expect to see less than 1 ohm would be considered continuity. And you might want to remember that if you're taking the test. Primary injection. Primary injection is the best test for checking the overloads on the breaker or the protection. You might want to remember that too if you're taking the test.
Or the overcurrent trip device and the coils there.
That is correct. Now, some newer designs, the digital type, have self-protection, and we'll take a look about that in section 3. The older design, the beginning generation, the electromechanical, this is the only way to actually truly test to see if they're within their band. Now, you have to use the coordination studies that are designed by the manufacturer to verify if they're within their band. Now, we're looking at these basic typical tests. Quite often, people who test this breaker will choose a value, normally 300% of the rated current or of the protection device, and then shoot it and make sure it's in that time band. That is only one test. If you take a look at IE, we'll take a look at the long time. There's actually 2 tests that are performed here. The very first one is pickup. Pickup has nothing to do with time. And when you're performing long time, short time, and ground fault, you must keep in mind that you do pickup testing and then time delay. You'll see that there's also not a time delay associated with instantaneous, and that's pretty self-explanatory because instantaneous is as fast as the breaker can come offline. Typically, long time is in seconds. Short time is in tenths of seconds, and instantaneous is within hundredths of seconds. And ground fault tends to mimic short time, except that the current values are much lower. Secondary injection. In between electromechanical and protection that the self-diagnostics, we had the solid state design. When this particular design came out, they came out with units that would simulate a fault into the protective device. The only challenge that you have with these particular designs is it does not check the CT, the wiring, polarity of the particular inputs to the protective solid-state device.
Just to clarify, the key difference here that you have to remember is primary injection testing will check the CTs, the wiring, and so forth, and of course, the overcurrent trip device. The secondary injection testing does not test the CTs, the wiring. It only tests the protective device, the overcurrent trip device. So secondary injection, and that's why we were saying earlier that primary current injection is considered a better test because it's a more comprehensive test.
For those of you taking the test, you might want to remember the very first paragraph. The timing test measures the amount of time it takes from the time the coil is energized to the time the arcing contact touches or separates. One of the main ideas with the timing test is that what it does not tell you is the overall condition of the equipment. Quite often, I will hear people say, well, our timing's good, so the breaker's got to be operating correctly. And it's not truly true.
There's plenty of other things that the timing test only tests certain components in the breaker. It does not give you a complete picture of the overall condition of the breaker. It doesn't tell you anything about the arc chutes and other parts of the operating mechanism and so forth. So it's just one window, one tool in your tool bag.
The next couple of slides we're going to take a look at are actual coils values. Now the X coil is your closing coil. In this particular design, it's also called the CC coil. Normally, the breaker operates under normal operating conditions. What we find is the best way to test it is normally at 70% of that nominal voltage. But you don't want to keep voltage on that coil longer than a couple of seconds. And what this basically will do is it will give you a margin of voltage that you know that the piece of equipment will function. So if it functions at 70% of its nominal, you can be pretty well assured that it'll work at its nominal voltage for the life of the time that the breaker is in that cubicle. We're also going to take a look at breaker operation optional testing, and then we're going to take a look at what we just spoke about. Now they can be done to all the tests, all the coils that are actually within the breaker. The X coil, the Y coil, you can do the minimum trip voltage, you can do pushed trip voltage, minimum closing voltage, and again, do not keep the voltage on these coils for long periods of time. Now the reason we're going to be taking a look at the Y coil is this particular coil can have voltage for extended periods of time, and it is your anti-pump circuit. In other words, this particular coil allows one attempt to close at a time. Breaker trip coil testing. Now, again, We want to check the minimum voltage on the trip coil that is needed to open the breaker. Now, what we're trying to say here is, with the closed coil, we set it up so it closed at 70% of its nominal voltage. Another way that you can do the testing is you can start off at a lower than 70, 50% of the nominal voltage, or whatever your plant or designate, and then run the voltage up by some value, 5 volts, if you will, and then push the close or trip button and let it go, and see if the breaker trips. And then continue doing that and make sure that it does trip at the minimum voltage, which is typically about 70% of the nominal. We're looking at the torque wrench. This is pretty standard. Keep in mind that you always want to torque from the nut side, not the bolt side, and that the threads on the bolts you want to have dry. One of the tests that we highly recommend for incoming and outgoing as a must-do and as a good indicator of the piece of equipment is a force gauge. Very early on in breaker designs, in the early 40s, 50s, 60s times, many force gauge tests were done on the springs, and now they are not, in today's breakers, are not truly done as much. There are more force gauges done in the operating mechanism.
And one comment on this, and we mentioned this several times in session 1, this is specific to breaker models. In other words, you have to review your own instruction manuals, the manuals from your vendor, to determine if there is any type of force gauge measurement. There may or may not be. It just depends on the breaker model and so forth.
Go, no-go gauge testing. Most manufacturers have them in their instruction manual, and basically what we have is we've actually shown you some of the upper picture of how they were made, and they're actually using a drill bit, ground, and then soldered or welded onto an end of a rod. And when you make a piece of equipment like this, you need to check it. And obviously we show you below that you want to use a micrometer to verify that it's within the tolerated tolerances or spec of the manufacturer. Because after multiple uses, you can actually reduce the size. The next item is we're going to look at a travel analyzer. Now, a travel analyzer is a good test, because not only does it perform the minimum pickup of the coils, it also shows you the speed of which the moving contact structure moves, and shows you ringing, as well as a graph that can tell you more information. And you actually see a little printout graph of a travel analyzer. Travel analyzers are typically not used because they tend to be cumbersome. The information you get can be interpreted in more than one way, and they are not easy to set up. You may require some form of a jig to actually get it to work on particular breakers.
Yeah, this requires special equipment. Again, if you don't do overhauls in house, you're likely not to have this equipment. It requires special jigs and so forth. Your service shop that does your overhauls, or your manufacturer, or whoever does your overhauls, they may have this type of equipment, and hopefully they're running this type of test, because it is a good test to do, especially after an overhaul.
Reduced control voltage testing, as we spoke about with the X and the Y, one of the items that comes in very handy is this particular picture shows a rig that can be mobile for operating a breaker from anywhere. It can be brought out to the cubicle and can be used to open and close and check anti-pump.
That's a fairly simple setup. Most power plants would like to have this type of equipment in their plant.
The next one to take a look at is over potential testing. You have two basic types. You have alternating or AC and DC. One of the reasons measuring is chosen over potential testing, it tends to be much safer. When you do over potential testing, it can be dangerous to the personnel as well as do damage to the equipment, and vacuum bottles, if it's done incorrectly, can emit X-rays. A little more on AC high pot testing. Some particular AC units actually use a pulsating AC or a square wave, so that the wave is not true. It's considered destructive, but is also considered better than DC. And one of the main reasons, because it stresses the insulation in two directions, it's 60 times a second, and is more of the real world of what the piece of equipment is going to see. The next item that you'll be looking at, or should be up on your screen, is the DC over potential testing. And again, some DC units don't actually produce DC. They produce a square wave that goes from 0 to some value, and that's or a pulsating DC. And you must be careful because, again, do not exceed the maximum voltage, especially when checking vacuum bottles, because they can produce X-rays. We're going to look at a power factor. Now, power factor is kind of a difficult thing to explain, or people don't really understand. In session 1, we looked at MVA versus wattage, and what is an MVA rating. Power factor, what it looks at is it actually looks at the phase angle between the voltage and the current, and gives you some sort of value. Power factor is not necessarily good in certain pieces of equipment that you will not have degradation in the insulation resistance, also known as K constant. A little more on that by a manufacturer. Should be coming up on your screen soon. Doble. Doble is a company that has used power factor very well in their world, and they've come up with a database of what new equipment should look like and what degraded equipment will look like. And what they've done is they've built special software, a staff of engineers, and a database for using power factor. Some of the other less items, or less known, or less used, are oil breakers, and so we're just going to kind of look at those because they're a little inside the box of our particular 15 kV and below breakers. And again, you want to take a sample of the oil and have it sent out and looked at for any type of certain type gases indicate certain type of problems. You can also do insulation resistance testing, and we have a couple of what would be a minimum value, 17.5 kV or higher is what you would expect to see. And if you're doing these types of tests, at the bottom we have a couple of ANSI colors and standards that can be followed. A little more on that, about the testing of the oil, basically how it's done. And what it would be done in. And that pretty much concludes all of the testing and test equipment that is used on circuit breakers. The last item we're going to take a look at is items that didn't necessarily fit into any of the above. So we're going to take a look at some notes about the manufacturer, key ideas, foreign material exclusion, fuse testing, building parts kits, component aging of electrical devices, and bad parts. And one of the items you must keep in mind is that the distributor of the equipment may not be the manufacturer of the piece part that's in the breaker, i.e. motors, coils. So it's important that not only you contact the manufacturer, but you can also contact the manufacturer of the piece part. And keep in mind, common sense applies. And the last bullet. When you get some information from any manufacturer, the best way is written. Verbal is okay, but you'd be surprised that when you ask for it in writing. Key ideas. Just because you find it that way doesn't mean you put it back that way. That's true of spacers, which are a huge challenge, and springs, and upgrades within the piece of equipment breakers that have been implemented by the manufacturer. Just because it works doesn't make it right. Just because you're outgoing testing, you get it to work and pass, doesn't mean it was assembled correctly. All information must be tempered with common sense. Information about one type of breaker manufacturer is not applicable to other types or of the same type breaker by that manufacturer. Foreign material exclusion. Again, you want to keep the area clean. You want to bag parts, label them if required. You want to make sure your tools are accounted for. Fuse testing. If you have a fuse breaker, you must remove the fuses and shunt them out before you do any high current injection testing. When you're looking at fuses themselves, you want to investigate any fuse that the resistance value measures a different value between one to the other at 15%. Building parts kits. One of the main ways to build a parts kit is during the disassembly of a breaker is to identify the quantity and type of each piece part that needs to be replaced every time. And you want to identify parts that you see a trend of failure. And in this case, you see in the picture, we actually have a board that has a set of those particular parts with the part number for easy reference. And then what we're going to look at is component aging of electrical devices. When we look at these particular pieces of equipment on the breaker, fail or tend to fail digitally. Just because you test it and it works correctly doesn't mean it's going to continue to work correctly. So if you start to see a trend of failures with any type of electrical device or component, i.e. motor or relay, you might want to consider before the failure of making those part of what we just talked about, the parts kit, or having those on hand. And the last item I want to take a look at is bad parts. Incorrectly made. Just because you receive a brand new part from the manufacturer doesn't mean that it was made correctly. As we spoke about earlier, the quality of the technician, or his ability to be able to do the work, training, to understand what is right and what is wrong. Don't assume that you get something from the manufacturer brand new that it is correct. The other item is a failure over time. When you're looking at plastic and nylon, and these springs, these parts tend to wear out. There's lubrication in the switches that are self-sealed, and you want to try to stay or do not reuse parts that are designed for a one-time use. Lock nuts, cotter pins, squeeze retainers. Then we have some applicable references where some of this information was pulled from.
Yeah, these are just some references we put in the presentation. You can read that at your leisure. That pretty much concludes session 2 for this week. What we're going to do now, I'm going to give Gene a little rest here and let him read some of the questions that came in. We've got about just a few questions here. I'll be answering one of these while Gene reads the rest of them. One question was, should breakers be overhauled on a number of operations basis or a time basis? And the question was, just in general. Some manufacturers will cite both in their maintenance manuals or their instruction manuals or their bulletins, whatever you want to call it. Literature from the manufacturer, they might state number of operations, they might state time-based, or they might state both. So the question is kind of difficult to answer. It should be you really need to consider both. If a manufacturer recommends that you perform a PM on X number of operations, and say it's the breaker's located has a load that doesn't cycle very often, and the breaker is not cycled at all, then you want to kind of discount the PM on the basis of number of operations and really look at the time base, because the breaker could be in there in the cubicle for a while and not be cycled at all. Certainly that's true for you new guys out there. You know this all too well. Nuclear power plants, that's the primary problem. The breakers just aren't cycled at all, except during PM. And at some other plant or some other application, it might be cycled a lot. So you really have to consider both, and kind of, as Gene said earlier, kind of use some common sense there. You don't want to go too many cycles, and you don't want to go too long without performing a PM. So the best thing to do is look at your own, in session 1, we discussed a lot of the things that you need to look at when you determine maintenance frequency. And the person that asked that, I would refer him back to the session 1 presentation. which is loaded up on our website, and if you weren't with us last week, you can go look at that. But really, the answer is consider both and use your common sense, and also the experience, the operating experience at your own plant. You need to look at all of that.
All right, we have a couple of questions that I'd like to talk about. What do you consider high pressure air? Before we talk about the high pressure, you have to actually have a relief valve on the front of them for the pressure. The nozzle has to have some way of the air actually escaping. I'm not exactly sure what the...
You're talking PSI.
Normally, high pressure air there's a standard on that is in the...
Sure.
Normally, when I overhaul a breaker, I will use about 60 pounds of air pressure. 30 pounds of air pressure is typically what I find at most plants will let me use.
And this is dry instrument air?
That's just
Okay.
standard air.
Yeah, it's just, well, it would need to be dry instrument air, I suspect, right?
Or no, normally, as long as most of them have dryers on them.
Okay.
And then, but again, the correct answer is what your plant allows you and what they consider acceptable. And there are some acceptable guidelines according to OSHA standards, I believe, that need to be applied. Item 2 is caution should be taken to inspect the GE air magnetic arc chute contacts flexible shunt connections on the stationary arcing contacts to avoid the arc chute failure. I absolutely 100% agree with you on that. And care also needs to be taken when removing and installing the GE air magnetic arc chutes because of the inner plates. Sometimes you just can't pick that particular design up. And they also have a challenge with moisture, and power factoring for that particular design breaker is very effective, where it's not so effective with such as the ABB designs. And then again, I have in here that was just spoke about with the should breakers be overhauled on a number of operations or a time base in general, and I believe Jim Sharkey just answered that one. Item 4, is there any point in using IR on the front side of the medium voltage breaker, or is it only useful if you are able to see the conductors in the back using those expensive sight glasses?
Yeah.
Very good question. If the cubicle is seeing quite a bit of heat, if you're using an IR and you look at the total switchgear, if it's that hot, you can see a slight variation in the front of the door or the back of the door, but it has to be awfully hot to actually see a difference in temperature. What you will not be able to see is exactly where your problem is.
This is Jim. I can answer this a little bit. Just based upon what I've seen in the nuclear industry, we have in the nuclear industry started installing, some plants have installed these specially designed sight glasses where you can use an infrared camera to look inside the switchgear. In other words, beyond the cubicle doors in the front or back. But we don't have a whole lot of experience with that because really they've just been installed in the last few years. As far as using infrared cameras on the front side versus the back, again, we don't have. It's not really a standard practice on medium voltage equipment. It's not something that's done by every plant, so we don't really have a whole lot of experience with that. Yes, some plants out there do that, but as far as the effectiveness, they haven't gotten back with me, and I don't really know the effectiveness of the front versus back. I do know it has been used in some cases, and these were fossil plants, by the way, where it has been proven to be beneficial. Whether they found the heat coming off the front side or the back side, I'm not sure. I suspect it would be more than likely the back side. Yeah, Gene's shaking his head, yes. So on the front side, you don't have, you'd be less likely to see that. You've got the breaker usually in the bottom of the compartment, and in the top you have the what I call the instrument and control compartment, or some people call it the relay compartment. You're not going to see any I2R heating. So again, tough question there.
And the line side of the bus is usually protected by some barrier between the load side of the bus. So you can see some heat, but what you'll see is you will see a hot spot on the piece of metal. You won't see the hot spot itself. You just see the whole piece of metal kind of glowing hotter than the other cubicles.
What I would do is all switchgear is designed differently. What I would do is if you can, get a hold of your drawings of your switchgear, and just look at how your switchgear is constructed. Or if you have a bus outage, just go in there and physically look at what you've got and say, hey, what would be the best location to take infrared? So that would be my suggestion.
Next question. Is it true that most switchgear has a red light with the trip coil? Oh, excuse me. I'm going to blame my last. Is it true that most switchgear have a red light in parallel with the trip coil to prove that the trip coil is in circuit? And that is false. That is not true. What it has is the switchgear, the wiring is in parallel with the trip coil. And what happens is there's a small trickle voltage that is actually going through the trip coil the entire time, proving that the entire trip circuit is ready to actually function. In parallel, it wouldn't provide that information.
Yeah, Gene, I'm looking at the clock here, and we got just 15 more minutes. We have one more question on bolt torquing. Gene will get back to that individual via email. We have your email address, so we'll answer that question. But in the interest of time for everyone, we're going to move on here to the quiz. And what I would recommend, I'm going to operate the slides here, and Gene, you're going to read the questions. What I would recommend when you take those, for those people who are taking the quiz right now, I would highly recommend that you read all the responses and choose the best answer. We recommended that last time, and most of y'all did fairly well. As a matter of fact, I don't think anybody punked last time. We will give at least 30 seconds to answer each question. We'll monitor the responses and make sure that if you need more time, we'll give you more time. But with that, Julie, I think we'll go into the tough questions.
Great.
Okay. I'm going to just click on and move on. Gene, you want to read the question? This is question 1.
Why do we perform maintenance on circuit breakers? A, improve personal safety. B, reduce operating and maintenance costs. C, increase plant reliability. Or D, all of the above.
And because there's a delay in these slides, we're going to click, when we change slides, we'll click to the next slide and then pause and make sure everybody's reading the same question. It's like about 10 of you have not answered, so we'll stick with this one for a while. Okay. Looks like that's about it. We'll move on to the next question. I'll give y'all a minute to make sure the slide is up. Oh, we went back to the first one. Sorry about that.
Next question. Thermography survey should be performed during periods when the loading is A, at 40% of max, B, greater than 40% of max, C, less than 40% of max, or D, no current at all.
Okay, we're going to move on. Most everybody's answered that. We'll move on right now. Okay, you should have the next question up.
A visual inspection is A, as good as the visual inspection procedure or checklist, B, as good as the equipment being inspected, C, as good as the person doing the visual inspection, or D, all of the above.
Looks like most everybody's already answered that one. I'll give y'all a little bit more time. I'm going to give y'all at least 30 seconds on each of these. Okay, I think everybody's answered that. Moving on to the next one.
Question number 4. Generally, the auxiliary switch resistance should be less than A, 1 ohm, B, 10 ohms, C, 0.1 ohm, or D, 0.0 ohm. Blame my last. Delta was 0.01 ohm, as shown in the slide.
Read the slide.
Read the slide. Read the slide. I got it. Read the slide.
Okay, we got one more person that hadn't responded. Okay. Looks like we got almost everybody now. Okay. Alrighty. Moving on to the next slide.
Next slide. Question 5. Primary injection testing is better than secondary injection testing because the test provides a more realistic and comprehensive test of how the circuit breaker is going to operate under test load. True or false?
Just so you know, the polls were just closed, so if anyone is having technical assistance, they are now open, so sorry about that.
Oh. I see. We were wondering why no one was responding. I thought that was a fairly easy question, but it's showing up now. Thank you, Julie. We were wondering about that. Looks like one person is still not responded yet. We'll give it another There we go. Very good. Okay, we'll give y'all just another 5 seconds on that one and we'll move on.
Okay, this is kind of a long one. Question 6. What is the correct order for the movement of the main and arcing contacts during circuit breaker closing and opening? A. On closing, main contacts touch first, then arcing. On opening, main separate first, then arcing contacts separate. Distractor B. On closing, arcing contacts touch first, and then main contacts touch. On opening, main contacts separate first, then arcing contacts separate. Distractor C. On closing, arcing contacts touch first, then main contacts touch. On opening, arcing contacts separate first, then main contacts separate. Distractor D. On closing, main contacts touch first, then arcing contacts touch. On opening, main and arcing contacts separate at the same time, but only on Thursdays during a leap year.
This is Jim Sharkey. I think I'm going to reread that question. It was Gene. I think we set me up. I think myself and our staff assistant messed Gene up there. Not his fault. I'm going to reread that. What is the correct order for the movement of the main and arcing contacts during circuit breaker closing and opening? A. On closing, main contacts touch first, then arcing. On opening, main separate first, then arcing contacts separate. On closing, item B, on closing, arcing contacts touch first, then mains contacts touch. On opening, mains contacts separate first, then arcing contacts separate. C, on closing, arcing contacts touch first, then main contacts touch. On opening, arcing contacts separate first, then main contacts separate. D, on closing, main contacts touch first, then arcing contacts touch. On opening, mains and arcing contacts separate at the same time. It looks like we got a few people have not responded, so we'll give you all a few more times since we messed that one up. Sorry about that, Dean.
That's right.
You can blame that one on me. All right, looks like everybody's answered that one, so let's move on.
I apologize about that last question. Question number 7. One of the most common errors made when lubricating a circuit breaker is A. Under lubrication. Distractor B. Over lubrication. Distractor C. Wrong lubrication. Or the distractor D. No lubrication where required.
Looks like we got one person we're missing. We'll give them a few more. There you go. Very good. I think everybody's answered that one. We'll move on.
Next question. Silver oxide is a hard black substance that A. does not need to be removed, B. needs to be removed, C. does not conduct electricity, or D. requires abrasive pads to be removed.
Okay, looks like everybody's answered that one. Final answer. Moving on. Well, wait, we have a few changes there. Yeah, okay. Moving on.
SBOM testing typically includes visual inspection, insulation resistance test, reduced control voltage testing, and low resistance ohm meter testing. True or false?
Looks like we're still missing one last person. We'll give them a little while longer. Okay, we'll move on here in just 5 more seconds. Okay, I believe this is the last question.
Timing test measures the amount of time it takes from the time the coil is energized to the time the arcing contact touch or close or separate, trip open. So the timing test measures the amount of time it takes from the time the coil is energized to the time the arcing contact either during close touches or when tripping open, the arcing contact separates or opens.
Okay. Looks like everyone has answered that one. So we are going to review the answers to the test questions.
We have one more question.
We do?
Yeah. We have one more question.
Not today, we don't. That was it.
No, it's not.
Full 10. No, we've done 10. Okay. We're going to review the answers to the test questions now. Any objections, Julie?
Oh.
That sounds perfect.
All righty. We're starting to run over on time here. I apologize, but we're just going to go through these real quickly. Question 1, why do we perform maintenance on circuit breakers? The answer is D, all of the above. To improve personal safety, we reduce operating and maintenance costs, and we increase the plant reliability. All very important and all correct. So the answer is D. Question 2, thermography surveys should be performed during periods when loading is, the answer is B, greater than 40% of maximum. If you just think about that, you'll understand that why you need a greater load on that to detect the heating there. Question 3, a visual inspection is, answer is C, as good as the person doing the visual inspection. You need to have a fairly person that's knowledgeable with the breaker and knowledgeable about what can go wrong with the breaker. So you need a qualified individual that's inspecting the breaker. Question 4. Generally, the aux switch resistance should be less than. The answer is A, 1 ohm. Gene covered that, I think at least once in the presentation, maybe twice. Question 5, primary injection testing is a better test than secondary current injection because the test provides a more realistic and comprehensive test of how the circuit breaker is to operate under the test load. That is true. It tests the CTs, and the polarity, and the wiring, and the overcurrent trip device, where the secondary current injection only tests the trip device. So the answer is true. Question 6. This is the one we read wrong, but corrected our mistake there. Question 6, what is the correct order for the movement of the main and arcing contacts during circuit breaker closing and opening? The answer is B. On closing, arcing contacts touch first, then the main contacts touch. On opening, main contacts separate first, then arcing contacts separate. The purpose of the arcing contacts is to they're kind of I don't know if I'd say destructive in nature, but the arcing contacts are to take the arc and the pitting. And Gene mentioned that on arcing contacts you'll likely have pitting, and
the object of the arcing contact is to protect the main contact, because after the breaker is in the closed state, the main contact will carry the majority of the load.
Yeah. So, question 7. One of the most common errors made when lubricating a circuit breaker is B, over-lubrication. We mentioned that several times in session 1 and covered it again in this session. Question 8, silver oxide is a hard black substance that A, does not need to be removed. The answer is A. It is as good or better a conductor than silver or copper. Question 9, the timing test measures the amount of time it takes from the time the coil is energized to the time the arcing contacts touch on close or separate on opening. True or false? The answer is true. Question 10, last question. As-found testing typically includes visual inspection, insulation resistance test, reduced control voltage testing, and low resistance ohm meter test. Again, that is true. That concludes today's session. I hope y'all got something out of this. I know me and Gene enjoyed presenting this. The third and final session is next Monday afternoon, June 27th. Again, we'll be covering cubicle maintenance and safety with regard to breakers and switchgear. So with that, I think we'll adjourn. If you have anything, Julie?
No, just as a reminder, you may now print a copy of the presentation. Simply select on the file and select the print to PDF option. Also, did you have any final words or thoughts that you wanted to leave with our listeners?
No, I didn't. Gene, you have any? No, Gene has none. We thank you for participating, and we'll talk to you next week.
Great. Again, thank you, Jim and Gene. At this time, this does conclude today's live meeting event. You may now disconnect your line. Thank you for joining us, and have a great day.